Hello everyone. So this video is going to be the start of a series, just keeping track of the progress I'm making on my big project. So this project is going to be actually building a working computer, not a massive thing, just your typical SAP1 computer. If you've watched videos like Ben Eater's, then that's basically what he built. But I'm not going to be using breadboards or ICs. I'm literally going to be doing everything on perf board, every single component, soldering it all that stuff. So some of the videos I've already done, my decoder stuff, that's been part of this. So I think it would be just be better off in its own series, so it's not all over the place, and I don't have to make individual videos for each part I'm working on. So this was the first decoder I built, a 2 to 4 decoder, and the plan was to build 5 of these. I've currently built 2. Here they are. So there's another one, and there's another one. So you'll see these ones don't actually have the pins for the wires. So this one's sort of like configurable. You can change this about and actually use it for different things, which is something I wanted to do, but yeah, look at all that, it's nonsense. So these are just soldered directly. So all these lines are all down here. So you can see the difference on the bottom anyway. Yeah, that's it. So you can see there's a few more lines on this one, and I can't remember which was the first board. Oh yes, yeah, this is the first. This is the first board I did like this. So there was actually a few mistakes, and I had to go out the top here. I don't know if you can see that. There's a few jumpers there and one there. That was just because I could not lay it flat on here, so I had to do that. It's no biggie. I've actually done it on here as well. This was a lot quicker to make because it's literally just a copy. And yeah, one thing I'll note about this is you can see the solder on here is a lot better. It's a lot cleaner and shinier. That's because I ran out of my previous solder, and then I switched to this other solder, which was really bad. It was terrible. I didn't think it would be so awful, but yeah, it's really dull, and yeah. But this one, I bought a new solder just for this, and oh my god, it's so shiny and so much easier to work with. Like this, I'll show you the solder. Yeah, the solders. So this was the bad one. If you see this stuff, just avoid it. It's awful. It doesn't have flux built into the wire. You actually need a tub. And this is the tub I got with it, and you know, some badly translated Chinese there. Favourite is "no poison, no erosion." Nonsense. It's just awful. Even with that, dipping this in it, then soldering it, it helps a little bit, but just don't use this. I had to have my soldering iron up to like 400 degrees Celsius to get that to do anything, and it literally killed that in a day. I might try and fix this with a new solder, but it killed that the same day. So just avoid that. And this is the stuff I switched to. So this stuff's made in Germany, and it's by Weller. This stuff is amazing. It's a bit thicker. It's 1mm, but it's so easy, and it works at like, I don't know what I've got it at. But under 250. It could probably go. I mean, I guarantee it can go lower. Probably go to under 200. It works so well. So recommend that stuff. Anyway, yeah. So that's why that one's really nice and that one's a bit dull. But they both work identical. You can see I've also put some legs on this one. I figured, seeing as I need 5 of these and they're all going to be attached, I would just stack them like that. Although I actually need to get more of these spacers, because you'll see here, these are 10mm spacers, and they don't fit with the terminal blocks there, which I use for the power. So yeah, that's annoying. So I have ordered some new ones. Don't know if they've turned up yet. I've got a couple of parcels here. I'll open them in a sec. Although I don't think I've got the spacers yet. So other than this, this is just the decoders. This will ultimately end up 2 more of these boards. Although I'll probably make 3 more, so I don't have to use this. That will be my 4 to 16 decoder. And that's going to go into this little diode matrix, which I haven't soldered yet. I was going to solder it yesterday, but I was ill, so I didn't. This went here, I think. So, yeah, I've laid it out here. So you have 16 inputs and 7 outputs, and this will basically go out to a 7-segment display. So this is hex, so it's 0 to F. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. I had to design this bit. Although, well, I say design it, I mean, I just laid out the schematic here. Well, the pin out, or what the segments will match to, and then just how the diode should be laid out. Haven't actually soldered this yet. I was going to yesterday, like I said, but ill. So what I'm going to do is, so this is going to actually, the output side of the diode is actually going to be, did I just lose one? Okay, that's not fun. I'm going to have to put that back in somewhere. Yeah, they'll go right down here, but the input ones, because the inputs have to go all the way along, they will just jump over like that, little arcs. It won't be, there'll be enough space there. And this actually fits on the same board as these, so it could probably be part of that. I don't know yet. Oh, where did this come from? Let me see if I can find it. Not that one. 2, not that one. Got a feeling it probably came at the end here somewhere. 4. Okay, it came out here, I think. Right there. So that just bungs in there. Oh, maybe not. Oh, wait, what? What have I done here? Oh, it goes that way. I don't know, I'm going to have to take all them out when I solder anyway, so I'll fix it then. So yeah, that's the components I'm working on at the moment. I have actually laid out a 7-segment display, but I took it apart, and I haven't got it built up like this one yet. So I need to take this apart and resolder it. So I've got a few new bits to help build this. This could be multiple things. I think it's actually LEDs, but we shall find out. Oh, why do they have it perforated and then impossible to open? There's some scissors. There we go. When things have tear here written on them and it's like impossible to tear. Right. Okay, no, it's my spacers. I thought this was actually going to be LEDs. It's actually my spacers. Brass ones. So these ones here were nylon. I have no problems with nylon, but you can get this exact same set in nylon, and the brass ones were £1 cheaper, so I just got the brass ones. Obviously, I think they'll look nicer as well. Yeah, those are nice and shiny. So, these were 10mm spacers. I'm going to try and replace them with slightly bigger ones from the new set. And hopefully that fits. Well, it will definitely fit a lot nicer. And I just dropped one in there. Get out of there. I'll find another use for these nylon ones, but I have a limited number of them, so I don't know how much useful they'll be. So, let me just compare. Okay, so that's like a 9mm. Oh god, that's got to be like 15mm? Gotta be. What's this big one then? Those are female to female. I thought these actually had 10mm in them as well. They don't appear to, but they do have much bigger ones, so that'll do. And these have nuts on them as well, so that helps. I can actually use smaller ones for the bottom. Let's try that. So you put a little small one on the feet. Okay, they don't have a very long screw holes. Well, they don't punch through very far. But should be alright. It holds. Smooth that up there. Very fiddly. But, oh god, I can't even turn it around. Right, here we go. These feel a lot sturdier. The other ones, it feels like you're bending the thread or something, or, you know, ruining the thread. I mean, I wasn't, but just feels like that. Right. Oh, okay, this one does not want to go on. What? That thread. Okay, it fits in. Oh, okay. Let's try a different one of them and see if it helps. That one wasn't quite nice. Let's try a different one of them ones. That's better. Okay, that one's a bit loose at the end. Not very nice. Right. There we go. And that should sit nicely on top of that now. Yeah, look at that. Perfect. Obviously, I'd have to change these connectors here. I could remove them and put angled ones in there, or I can just solder the same things onto there, hanging outwards. I'm not a perfectionist. As long as it's symmetrical, I'm happy. It doesn't have to be perfect. Yeah, I'm happy with that. See how that... Okay, I think I'm just going to have a few bad ones here. Most of them seem fine, so yeah, that's just a bad one. I can always use it as a foot or something, like as the bottom one. So it's not the end of the world. Yeah, I'm happy with that. That'll be much easier to work with. So there'll be 5 of these all stacked up in a big pile, and those will go into the diode matrix, which will go out to a 7-segment display. So let's open the other package, and then I'll have something else to talk about. Leave that there. So these, oh gosh, I believe are resistors. They came in a bigger package, but yeah, look, it says there 1000 1K resistors. Okay, it doesn't have a. Okay, that's it. That's literally it, just a big pile. And thankfully, they are the same as the ones I'm already using. Let me just try and find one that matches. So this was my decoder on the breadboard, and they are identical. So yeah, because the original resistors I had were completely faded, like the barcodes were completely faded when I got them. So I didn't want any more like that. I wanted these ones. So I'm happy. I can probably put a link to the eBay seller for these, because really handy to have. And these are 1010Ks. Oh, hello. Nearly forgot the rest of them. So I think these will keep me going for a while. I ended up... These seem to be these are the most common values I'm going to be using. 10Ks that go into the base of transistors, and 1Ks that go everywhere else, basically, to ground and to VCC. In the diode matrix, I'll actually be using 5K or 4.7K resistors into the transistors because uh, I think. See, this is where I start losing understanding. But yeah, because there's a voltage drop on diodes, they actually don't need 10K resistance on them. So I'll be using 5Ks. Now, I don't know if that's common practice, but I've seen that in so many places that I'm going to do it. I'll probably do a few tests anyway and see what happens. But yeah, that's... God knows where I'm going to put all this. They won't fit in my little trays. So... yeah, that's 2,000 resistors. And my spacers. Some other things I've ordered are more diodes because I have 200 diodes and split down the middle they're completely different. Well, they're the same. They're 4007s, but I have these ones from China. These are small. These are really small. And I have ones that are brought from the UK, and I think they're made in the UK as well. They're a lot thicker. They're a lot thicker than these. Slightly longer, maybe. I'm not sure. But they have thicker wires as well, so I don't really want to mix and match them. Even though they seem identical, as far as I can tell. I haven't hit a limit yet where they're different. There may be one, I don't know, but I ordered some more of these ones from China, so I hopefully get the small ones again. They were the same seller, so yeah, and they're a lot cheaper getting from China as well. It just takes a month. What else was I going to talk about? I don't remember. Oh yeah, so this computer, ultimately, obviously it'll basically be a SAP1, but I'm going to add a few things to it. So while it'll have an ALU, but it won't just be addition of subtraction. I want actual logic in there as well, so you'll be able to AND two numbers, OR two numbers, XOR two numbers, that sort of thing. And I mean, you'll be able to do multiplication anyway because you can just do that with addition and subtraction. But we'll see. There'll be a few more registers because I want to be able. It will be 8-bit, but I want to be able to represent 16-bit numbers as well. So you'll be able to split it up, and there'll be like a carry flag and stuff like that. So you'll be able to do arithmetic on two 8-bit numbers, then arithmetic on the second halves of those two 8-bit. Basically, it'll be a 16-bit number split into two 8-bit numbers, and you'll be able to do arithmetic on both using the carry flag and stuff like that. So I'm going to do things like that, and there are other challenges, like there won't be a ROM. Well, there will be a ROM for like the instruction set. That will basically be a diode matrix as well. Because I'm not using ICs, I can't just go away and program something. I have to actually make it physically. RAM will be difficult. I'm going to stick with the 16 bytes of RAM that SAP1 architecture defines. And that should be enough for some basic tests, and hopefully I can make it expandable so I can always just add more later. Because there's only so much you can do with 16 bytes of RAM, because that is your program and your actual memory for the program. So we'll see. What else? Well, the one challenge I'm definitely going to have is to do with the power supply. Obviously, a little breadboard power supply like that ain't going to cut it, because we're dealing with a lot of components. And yeah, so that's something I've been looking into. I've ordered some power regulators to play with them, but technically they are integrated circuits, so I don't know if I could get away with using them. I would actually have to build my own, which I have done with the Zener diode thing. A note about that Zener diode video that I didn't realise, because it was the first time testing them, I didn't realise that because I didn't have the resistor coming from power, I actually burned out the Zener diode immediately. So it was reading 4.5 volts, and I was like, oh, that's close enough, that'll be okay. Actually, that was completely broken. That was just because of the two resistors, the load resistor and the limiting resistor. The Zener diode wasn't actually conducting any current. I tested this later because I tried doing a second video on it and I realised, hold on, this just ain't working. And yeah, I replaced the Zener diode with another one, and it worked perfectly at perfectly 5 volts. So yeah, that's going to be fun because I obviously don't know what I'm doing there. But we'll see. Um, yeah, and another thing about this computer, it's going to have a sort of like an Altair 8800 front panel. So you have all the little flick switches, and um, you'll have the LED lights, and they'll be split up into. I'll probably split them up into octal like the Altair did, so you can read it as 3 numbers rather than 2 4-bit numbers. But I'll have the LED display, and that hopefully I'll be able to display both of that. So you can display in octal numbers and display whatever you're looking at as a hex number as well. I'm not sure about displaying it as a decimal number yet. I'll have to think about that. I mean, it's not necessary for me. It'll just be nice to have it. But yeah, I'll have the LED display on the front as well, and you'll have a little switch. Well, maybe a couple of switches to split between what it's actually displaying, like hex or octal or binary, whatever. So yeah, more on that in the future. This is just going to be a series to sort of just follow the progress of this project. I'll still do other projects that are just generally on my channel, but this will be in its own playlist, and it will be progress over time. Hopefully, my goal is to actually get this thing finished within a year, but I'm going to do it. I'm expecting it to take about a year. It's going to take a while because, like, the whole computer is going to be built like this. It's going to be all soldered together by hand, and every wire, every component is going to be by hand. So it's going to be challenging, but yeah, this will be following my progress on that. Thank you for watching, and goodbye.